All right, folks, welcome to another live weather and climate office hour. This one's going to be very California and Western U.S. centric, and I'm going to be talking primarily about the building heat wave in California, which will be the most significant of the season thus far in some parts of the state. Some of the broader context surrounding that and the impacts we'd expect to see, including the potentially significant fire weather event unfolding in Southern California specifically later this week into the weekend. And also the potential for a late season, call it better late than never, monsoonal surge into the western fringe of the North American monsoon region. It's been a really abysmal monsoon so far this summer, but this later surge looks a little more typical for something we might see in July, and that could affect parts of California pretty substantially with some thunderstorm activity in the next few days. So I'll talk about that as well. And then finally, I don't have any prepared material necessarily for this, but if anyone asks questions about the hurricane situation along the eastern U.S. coast and Atlantic, in particular Erin, which is churning out there out over the open waters and will bring some substantial but indirect impacts to the East Coast later this week, I can potentially talk about that at the end if we've got time, but I'll reserve that for the Q&A period. So I'll jump right into it in terms of the heat wave, and if you want some of this in written form, feel free to check out the Weather West blog. My most recent update from yesterday does focus squarely on this heat wave and the associated fire weather and monsoon event, as well as its broader context. First of all, I do tend to use the term heat wave fairly colloquially. There's a bunch of different formal quantitative definitions, all of which I think are unsatisfying, including scientifically. Frankly, my main criticism of them is that they're all way too rigid. And colloquially, heat wave just means a period of time that's more than just a day or two, where temperatures are notably warmer than average for a given place and at a given time of year. So a January heat wave, of course, in a given location would look pretty different than a July one, just as a heat wave in San Francisco at any time of year is going to look a lot different than one in Death Valley or Dubai or something. So it's all relative, literally, in this case. A heat wave does not connote record-breaking temperatures. There's nothing inherent to the term heat wave that means we've never seen it before. And there's nothing about a heat wave that connotes that it's some devastating event either. Heat waves can be quite deadly and have pretty negative side effects, but they certainly don't have to be. Sometimes it's just warm, and sometimes that can even be pleasant. But it really depends, again, on the context of where you are, how warm it's been, how warm it's going to get, and whether where you live is adapted to the magnitude of the heat wave you're experiencing or not. So with all of that in mind, this particular heat wave does not look like some earth-shattering event, although, especially in Southern California, in terms of daytime high temperatures in Arizona, and all throughout California and the West in terms of record warm overnight temperatures, there might actually be some August records set. In some places. And by August records, I should clarify, probably not monthly records anywhere, but definitely daily records within August. There's also some folks who don't even like to talk about daily records because essentially it's saying, looking at a particular calendar date and saying, have we ever seen temperatures warmer than this on any previous calendar date? So on any previous August 21st, for example. And I understand that criticism, which is that it's noisy. Does it really matter that it happened on the 21st versus the 22nd or the 25th of August? Not really, meteorologically. They're all similar calendar dates with similar smooth background curves in the seasonal cycle. So I don't think we should necessarily make too much out of isolated occasional daily records being set. But on the other hand, if you have a bunch of locations that set daily records at once, or you set a lot of daily records over multiple days, that does tell us that we are right at the upper end or maybe above the upper end of the range of temperatures that we experienced at this time of year in this part of the country historically. So it's more significant, obviously, when you break monthly records. So the hottest temperature, for example, ever experienced in August on any calendar date in August, that's a pretty significant number. Or the hottest temperature experienced at any time of year, or during meteorological summer or fall or something. Those are big deal numbers, and we've hit that a number of times, all of those kinds of numbers in many California locations in recent years. Not so much this year. In fact, I don't think any location in California has seen a new monthly or annual all-time high temperature this year, and I don't expect that to occur either during this heat wave, although some places probably will break daily records on a sustained basis, and that is still notable. So with all that context out of the way, talk a little bit about the upcoming event. It's just beginning today, but will probably peak between a Thursday and Sunday, depending on where you are in the state, with probably Friday being the hottest day in many places, but in some places Thursday will be the hottest day, some places it'll be Saturday or Sunday. So these heat waves, as they usually do, they evolve a bit differently around the state, but each day between Thursday and Sunday should be much warmer than average, essentially everywhere in California to some degree or another. And for the first time this year, this will include the immediate coast in most places. In fact, already today, seeing places like Point Reyes Station or the lighthouse out there with temperatures in the mid to upper 70s, which doesn't sound like a lot, but out there on the peninsula, out there in the middle of the cool water upwelling, it's actually a pretty warm day. For those parts. So the warming has already begun. Interestingly, it's begun along the coast, partly because we've lost that cool, clammy marine layer we've seen all summer. And we've also lost those really chilly near-shore temperatures. In fact, across along the north coast and down to the central coast, as well as in some pockets of the Southern California coast within the Southern California Bight, as it's known, the ocean temperatures are now warmer than average, which is a pretty dramatic reversal for what they've been most of the summer. And I'll show some data supporting that in just a minute or two. But what it does mean is that this heat wave won't necessarily be extreme heat to the coast, but it will be, for the first time, not cloudy, not drizzly. It will be sunny, it will be warm, and in some cases it will even be hot pretty close to the coast. And that is probably the first time this year this will have happened in northern and southern California at the same time. It will, of course, also be hot inland, but we have had hot temperatures inland already this season, although this may be the hottest heat wave of the year so far in some of those inland locations too, particularly in the just inland parts of Southern California, so downtown LA, the inland valleys around LA. This will probably be the most significant heat wave so far for the season. And the other part that I want to talk about is, well, there's really two pieces to this. One is that there will be a surge from the east to west of monsoonal moisture. It won't really be so much of a surface surge. It'll still be pretty dry relative humidity at the surface, but there will be a lot of moisture in the atmosphere at mid and upper levels, which is a pretty good recipe for some thunderstorm activity, but in particular elevated thunderstorm activity. So storms that aren't surface-based, but are forming in the middle atmosphere, which means that there will be an elevated likelihood of at least some isolated dry lightning, maybe not widespread dry lightning because there is enough moisture for the more developed thunderstorms to produce heavy downpours on a very localized basis, mainly in the mountains and deserts, although, as I'll point out, slight chance elsewhere too. But the problem in these air masses where there's a lot of moisture above the surface but where the lower levels are very dry is it tends to make the portion of the storm where it's actively raining very narrow, even if the rain is intense in a very small area, and it means that lightning strikes can occur completely outside of the region where it's raining. And it means that the downward airflow out of these storms in the form of downbursts or outflow winds can be significant, and so that can fuel lightning-ignited fires and push them along with the gusty winds, or can also influence the behavior of fires that start via other ignition sources. And to that end, Southern California in particular. Again, this is not so true in Northern California. Fire risk will increase in Northern California, but will not be notably high during this event. We'll see more grass fires, we'll see more brush fires start. There could be some problematic ones, but Northern California, this does not look like an extreme fire weather event this weekend. In Southern California, though, it's a bit of a different story for a couple of reasons. One is that it will be hotter in Southern California, but also the atmosphere will be more unstable, meaning that any fires that do develop will be burning initially in a very hot and dry environment, but also in an environment where the atmosphere will be quite unstable, meaning that these fires are likely to become quickly plume-dominated, so self-sustaining through their own wind circulation systems maintained by essentially the process of convection from the fire itself. So fires generating their own weather conditions locally in the form of organized smoke plumes, pyrocumulus clouds, and maybe even if a big fire develops this weekend, pyrocumulonimbus clouds, those fire-generated thunderstorms. Most recently prominent in Southern California last fall, in September, where if you recall, there was a similar pattern of record-breaking heat locally with a big monsoonal surge late in the season. We saw big fires with multiple hundreds of structures burned, so they were pretty destructive fires last September, along with record-breaking heat and thunderstorms. No two events are alike, but this event does look potentially a bit similar to that in terms of locally record-breaking heat, a pretty decent chance of thunderstorms, and also some antecedent conditions that increase fire risk. So in this case, we have the legacy of a failed monsoon pattern so far this season. So the mountains and deserts of, Eastern and Southern California haven't really seen much, if any, rain so far this summer monsoon season. Remember, in far Eastern and Southern California, one of the wettest times of year is is usually July and August, with summer thunderstorms in the mountains and deserts, very different from the coast in San Diego and LA or up in Northern California. This year, that's been pretty much a no-show until this weekend. So conditions are actually really dry, even drier than usual in the deserts and much of the mountain region of Southern California. Also, this was a super dry winter across all of Southern California. We did finally get some rain, but on many places it was only about half of average. So we remember the terrible fires back in January. It did rain after that happened, but it didn't rain enough to overcome the enormous precipitation deficit that had accumulated up to that point. So we have the legacy of this wet to dry whiplash event, as I've talked about before, from 2023 and 2024 into 2025, that facilitated abundant growth of grass, known as herbaceous fuel in a wildland fire context. So there's literally more biomass, more potential fuel for the fires to burn, thanks to those couple of wet years previously. Now, 2025, including the last winter, was really dry. The summer has been dry. Now, that's not unusual in LA proper, but it is unusual in the mountains to the east of LA and the deserts to the east, which is where the fire risk will be high this weekend. So we have this legacy of abundant herbaceous fuel loading from a couple of years ago, which is still there, except in places that burned either last September or this January. And there were some areas that burned significantly, so there your mileage will vary. But everywhere that didn't burn in the last 12 months still has the legacy of that extra biomass from two or three really wet years in Southern California. And now this very dry period that follows. Now we got a really hot period. We're kind of in a situation similar to last September. The good news during this fire event, potential fire weather event, although it looks potentially extreme from a heat and atmospheric instability, plume-dominated fire perspective, it does not look like there's going to be strong, large-scale winds. So there's no major offshore wind event like we had in January, nothing even remotely coming close to that kind of event this time around. There could be some breezy or even some gusty, stronger winds near thunderstorms, especially, and in the mountains, as often occurs during heat waves. But it does not look like there will be any major large-scale winds. So this is not a Santa Ana extreme fire weather event. This is a different form. And the kinds of major fires that you'd expect under these conditions occur actually in different parts of Southern California. This is less likely to have those kinds of brush and grass fires that quickly move into highly populated portions of the urban interface, although you can never rule it out with thunderstorm outflows. But in general, these are the kinds of fires that are more likely to ignite and become intense in the mountains of Southern California. So, of course, people still live up there. There's still transportation corridors. There's still mountain towns and vast swaths of critical ecosystems and forests up there. But it is a different kind of flavor of fire risk event than a wind-driven Santa Ana event. So this is not that. This is a different kind. Although, again, we did see terrain and fuel-driven and plume-dominated fires in the last September's thunderstorm speckled heat wave, and this one could be similar. And there is at least a slight chance of a more widespread outbreak of lightning across central and northern California as well as southern California later this weekend. That's more speculative. It's still a little too early to say, but if that happens, we could see a greater number of fire ignitions in more remote places, which always causes some problems, particularly in the middle of a heat wave. So that could become 10 or 20% chance of that being a bit of an issue, with some drier lightning strikes in a more widespread context later in the weekend after a few days of heat. We'll see how that goes. Yeah, so I think what I'm going to do is I'm going to start to show some data. So bear with me for a moment. Share my screen. Okay, so you're going to see a satellite view now. And what you're going to see, and it's going to verify that you're seeing what you're supposed to be seeing here. Yep. Okay, so bring my drawing tool up here. Change the color slightly. Let's do a lighter blue today for contrast. Okay, so there's a few things that are of interest. Right now, you notice that nice anticyclonic flow across the whole western U.S. You can see it's really across a broad region here, all the way from West Texas to the East Pacific and up into the Pacific Northwest. Well, you have this nice high pressure system here, and this is strengthening and radiating outward. And so there's that classic four corners high. And in this case, if you kind of look at where the center of circulation is, it really is literally right on the Four Corners region. When we talk about Four Corners, we mean the four corners of the states, Utah, Colorado, New Mexico, and Arizona, and we really do see that anticyclonic circulation is centered right there, but extends all the way west across California. And if you are let's say, if you look south or southeast from LA County right now, you'll see this arc of high cirrus clouds. If you look north from San Diego County, if you're in Orange County right now, they're right over your head. Nothing threatening, this is just a band of cirrus, but you can tell these clouds are moving mainly from south to north, which is not the classical direction for movement, and it means that at the surface, the winds are from essentially east to west, and aloft, they're from southeast to northwest. So we're getting all of that moisture and instability. You can see all these thunderstorms popping up along the Mogollon Rim and the Rockies, and all that, and of course northern Mexico as well. All of this will begin to move towards southern and central California later this weekend. If you want to check out the fire situation on this map, by the way, there are a few things that are pretty apparent, which is that there's really no notable fire activity visible from space right now in California. I expect that to change this weekend, particularly in this part of the state. But where we do see it right now is in the Great Basin, so some very large fires in northern Nevada, the central and northern Rockies, so we see that in Utah, and in western Colorado, so the western slope region, and there are some fires under the thunderstorm clouds in Arizona as well. And also, if I move up further north, you will also see that there's some very active fire activity currently up in the Bitterroots. So in western Montana, there's at least 7 or 8 fires I can see in there. There's all those little black dots there. You can see them, and then in northern Idaho as well, so the Sawtooth. So actually quite a bit of fire activity. Right now it's mainly across the interior of the West. I don't see anything active in Washington or Oregon. They got some rain from an unusual August atmospheric river last week, so that's part of that, although some of those fires are going to start to pop back up. with a prolonged heat wave up there following the rain. And again, nothing really of note right now in California. That may or may not stay that way up in Northern California, but I do expect to have at least a couple of significant fires in Southern California later this weekend, especially because we'll have some natural ignition potential. So folks often talk about how it's usually human-caused ignitions in Southern California, and of course that is true, and that will probably still be true in an event like this, but right now, to the extent that there could be some dry lightning strikes, there will actually be the potential, even if humans are careful and behave themselves and don't cause all those unwanted accidental sparks, that Mother Nature is going to provide them anyway in the form of lightning. So there probably will be at least some problematic ignitions in the next few days. Okay, so what's the pattern? Here again is some model representation of the current ridge that we're seeing. As I mentioned, it's centered near the Four Corners region, and so right around there, that's kind of where we see it. This is a map, by the way, the colors are the relative unusualness or anomalousness, so these are standardized anomalies of the middle atmospheric pressure pattern. So you can see that the maximum anomalousness is not actually right at the ridge center. So the high pressure system is kind of centered here. The maximum anomalousness is there. This has to do with the difference between the background state, blah, blah, blah. Long story short, the reddest regions are the places where the middle atmospheric high pressure is the most unusual. So keep your eye on that. This is earlier this morning. This is approximately where we are right now. So you can see this afternoon it's already expanding westward from Arizona, where the record temperatures are most likely during this event, into southern and eastern California. And you can see overnight hours this expands further. As we get into Friday, this axis sort of maximizes right along just inland of the coast and up into the Pacific Northwest. So sort of like this, that's the maximum unusualness ridge axis. But the main point is that it strengthens going into Friday and persists into the weekend. So this whole general area, unusually high pressure on the western flank of this Four Corners ridge. You can see really peaking up in the Pacific Northwest and BC. Fire season is not over yet, despite the atmospheric river up there. Weakening a bit this weekend over California, but the hot, dry, thunderstormy conditions will remain, and only slowly fading as we get into early next week. Going into Monday, we still have anomalously high heights. Again, to Tuesday, Southern California starts to get out of it a bit, although it persists across Northern California into the Pacific Northwest. And then we get a little bit farther out, and it's probably better to use the ensemble once we get that far out. What does this look like in terms of surface temperatures? Well, right now today, it's starting to get warmer than usual. As you can see, parts of the coast, Southern California, this is today. So it's warm by this evening. It'll be considerably warmer than average across almost all of the West. But tomorrow, you start to see some pinks and purples. So that's 12 to 15 degrees centigrade, about 20 degrees above average in some spots. That's quite a significant heat wave, magnitude-wise. On Friday, it persists, although some of the greatest anomalies are up in the Pacific Northwest, up by Portland. Those are some 16 to 20 degrees centigrade anomalies. Again, that's like 25, 30 degrees above usual. We see some bright pinks in the San Joaquin Valley, some bright pinks in the northern Sacramento Valley. Friday is going to be an awfully hot one, and as you can see, this does extend all the way to the coast in a lot of regions in California. And this persists. This is Saturday, another really hot day, especially in the inland valleys of Southern California, the southern San Joaquin, the northern Sacramento, and then the Willamette Valley up into eastern Oregon. Still hot this is Sunday evening. As you get into Monday, still hot on Monday just about everywhere, especially up in the Pacific Northwest. It's starting to fade a little bit in Southern California and along the California coast by Monday, but still really hot in the San Joaquin, northern Sacramento Valley, and in the northeastern interior of California. And as we go through Tuesday, still, again, fairly persistent into things cool down maybe by next Wednesday or Thursday, although in the afternoons remain above average across most of California. So that's what this looks like from a temperature perspective. Now, I want to show, this is a slightly more complicated plot. This is the 700 to 300 hectopascal relative humidity plot, along with some wind barbs. So the arrows are essentially pointing the direction to which the wind is blowing. So for example, in this region, they're from the southwest to the northeast. In this brown region here, the brown colors are, and what this really means, the 700 through 300 hectopascal, what this means, essentially, the relative humidity is, it's an average view of how much moisture is in the middle levels of the atmosphere. So 700 millibars is a few thousand feet off the ground. 300 millibars or hectopascals is all the way up at the elevation that jets fly. So this is a measure of the average humidity in the atmosphere from the top of the coastal mountains to the altitude at which jet aircraft fly. So it's kind of ignoring just the lower part of the atmosphere, giving you a sense of elevated moisture. So you can see there's dry air right now over central California, moisture air over Arizona, but look what happens next couple of days. Moisture air aloft does come in over California. It's not too impressive on Friday, but then look what happens as we get into Saturday and Sunday. Some potential significant pulses of moisture air do show up. Another way of looking at this is to look at the total amount of moisture in the atmosphere. Again, right now, going back to the present, nothing notable over California, but look what happens as we go into the weekend, is that big green blob. This term, by the way, precipitable water, does not mean precipitation. It is a completely different quantity. Just think of it as the total amount of water vapor in the atmosphere. This doesn't even necessarily mean that there are clouds in the green area. It just means that there's a higher amount of water in vapor form. As you see over the weekend, as we get into Saturday and Sunday, there's a pretty unusual amount of moisture in the atmosphere above California and the Great Basin. So again, this is not so much occurring at the surface, this is more moisture we're seeing at upper levels of the atmosphere, and we see that continues through Monday and Tuesday. So this is the source of concern. It's going to be hot and dry in the low levels, but a lot of moisture at the upper levels. That could potentially cause some issues when it comes to potential thunderstorms. And I'm going to shift over to a different model. This is the American model now. But essentially what this is just showing is simulated satellite imagery. So this is giving us some sense of what the clouds are doing, and we can infer some things from that. So right now you can kind of see, this is where it thinks we'll be right now, doing a pretty good job. You can see the thunderstorms over Arizona. You can see that band of high clouds I noticed on satellite. Well, fortunately it shows up in the model right now, so indication it's on track. And as you see through the weekend, so we go through Thursday, and these are just more high clouds swinging up. So you'll see some nice high clouds, maybe a pretty sunset on Thursday, central and northern California. You see thunderstorms blowing up again over Arizona. But look what happens as we go into Saturday and Sunday. Now we actually see some enhanced cloud brightness, meaning that the clouds are taller. The brighter they are, it actually means the colder they are, which means the taller they are. And once we start seeing these oranges and yellows in isolated bases, as we see here over LA and Ventura counties on Saturday around noon, that starts to indicate that there might be some elevated thunderstorm activity. And this does suggest that some of this may move closer to the coast. So, and we see that this moves northward across central and northern California Saturday evening. And then there's maybe another round of that starting up as we go later into Sunday into Monday. So this does not necessarily mean that there will be a lot of precipitation. This is for all of those bright clouds, this is how much precipitation shows up in this particular model. But one thing to note is that the weather models usually do a bad job at these easterly waves, monsoonal events during heat waves, so don't take it too literally. The more interesting thing is that it does paint some non-zero precipitation across most of Southern California. Now in practice, what this will likely mean is there'll be isolated and scattered thunderstorms, and a few places may see some heavy downpours, a few places may see sprinkles, and then some places may even see lightning with no rain, which would not be great from a fire perspective, but it's a little bit difficult to know in advance which places will see which. There's also some precipitation up into central California and a bit more up in the mountains. It's not surprising. The Southern California mountains and the Sierra Nevada and the northern mountains up by Shasta will probably see some decent thunderstorms with this. But the real question is, will we also see it along the Southern California coast and maybe west of the Sierra Nevada in northern and central California too? That's the question mark. And I do think there's at least some possibility that will happen this weekend. So that's something to keep a close eye on in terms of the potential for some drier lightning that could ignite fires. Now again, if we go over to watch duty, what we can see right now is that there really aren't too many fires of major concern right now, although just in the last few hours there are a few new ones that are already beginning to pop up. And you can see the region of red flag warnings or red flag watch. There's none in Northern California for this event, but there are some in the mountains of Southern California, especially the transverse ranges all the way from San Luis Obispo County eastward into the Angeles National Forest. I would add that there is a fairly high fire risk as well further east into the San Bernardino Mountains and perhaps the mountains of San Diego County as well, even though they're not technically in the red flag region right now. So what does this fire weather look like? Well, here is the federal page for the hot, dry, windy index, which is, I think, fairly self-explanatory. It's intended to be a fire weather index that's replaced, for those in the fire weather world, the old Haynes index from some years ago. There's better empirical evidence this actually tells us something meaningful about the fire risk. And this is actually a clickable map. You can follow this URL later. But I've already pre-clicked to a region in the mountains above Los Angeles, and there's a couple of things I wanted to show here. One is that here we are today. We see some elevated fire conditions today, but nothing really extreme. So we're kind of right on the cusp of, I guess that's 3 colors in. So we're up at about the 75th percentile. So, elevated fire risk, but nothing dramatic. We get into tomorrow, though, and then we're going to be above the 90th percentile, which is starting to get a little spicy. We get into Friday, and that is a very high value. That is well above the 95th percentile of the hot, dry, windy index. In fact, there's even some individual members of the weather model that go to pretty extreme levels up here. So this is the median is somewhere in here, but some of the outlying members are way up here. So, we potentially see elevated days continuing for a few days following that, especially if we look at a slightly different region. You get slightly different answers. Let's just pull up a place elsewhere in Southern California. So here it peaks 2 days from now, rather. I think that's the same actually, and remains elevated. We go a little bit further up into Ventura County, for example. Similar kind of story, but remaining elevated, but not as extreme as it will be on Friday. So Thursday, Friday really look like the biggest days, but for any fires that do begin, the conditions will remain quite elevated relative to how they have been for some days thereafter. Now, if we go into the eastern San Francisco Bay Area, again, you see that we will be elevated at times, including getting up to around the 90th percentile, but not up in this territory where we'll be in Southern California. So this is elevated but not extreme. Similarly, if we go to, let's say somewhere in the northern mountains up by Shasta, again, this is not an extreme fire weather event up there. Elevated relative to how it's been, but nothing all that extreme. And if we go, let's say western slope of the Central Sierra, right about here, it is a more elevated event, especially as we get toward early next week. But again, not up in that 95th percentile. So this is mainly a Southern California risk event, which as I see it right now. And one reason for this is if we look, for example, this is the current assessment of 100-hour fuels from the Southern California Geographic Area Coordination Center. 100-hour fuels are essentially, large branches on the ground. So it's sort of not full tree trunks, but vegetation, dead vegetation that has an intrinsic response to weather and climate conditions that's much longer than, say, grass or twigs or something. So a little bit more memory. And the lower the values here, the more flammable the landscape, the drier the vegetation. And what we see is that recently we've been actually near record dry 100-hour fuel moistures. This is in the southern region in California. at least as we were in mid-August. We saw a brief spike right now, but it's going to go back down to near record values for the date this weekend. So that's part of why we're seeing what we're seeing. We have a hot, dry, unstable air mass conducive to plume-dominated fire behavior, and then at least in some patches in Southern California, we've got vegetation that will be at or near record dryness levels. And accordingly, what we've got are a plethora of heat and fire warnings, watches, and advisories in effect. Extreme heat warning for a good portion of hottest desert regions of Southern California, Southern Arizona. This is where the greatest likelihood of record high temperatures will be. Heat advisories, a lesser heat warning across much of the California interior, including eastern and higher elevation portions of the Bay Area, and even the interior of Mendocino, Del Norte counties, etc., parts of the Great Basin, and then up into Oregon. Far northern California actually under an extreme heat warning, once again, a higher tier. And then buried in this are some of the fire weather products down here. The Weather Service is predicting, as I mentioned, some record high temperatures, so really none today, which is expected, possibly a few tomorrow. So any time that there's a number on this map, the predicted temperature is either at or near record highs, so near tying or just above daily record highs. There's some soft records up by Sacramento, Stockton, it looks like, on Thursday, so we might get close. Lancaster and even downtown LA potentially near records on Thursday, but the most number of daily high temperature records is probably going to be on Friday, as I mentioned, the hottest day. Some parts of the San Joaquin Valley have some records within reach, some interior valleys of Southern California. Needles, California, that 115 might be a record, the 112 in Phoenix might be a record. You might say 112 doesn't sound like a record in Phoenix, hasn't it exceeded 120 degrees there before? Well, the answer is that usually that happens in June or early July, not this late in the season, because usually by now the monsoon is cranking, so it is unusual to get this strong of a ridge, even in the hottest deserts of southern Arizona and southeastern California this time of year, which is why some of these numbers are records in already hot places like Las Vegas and Needles, California, and Phoenix, Arizona. And then the records, a few up in far northern California, southern Oregon, still possible over the weekend, but then it shifts northward into the Pacific Northwest. What is interesting, though, is that the number of overnight warm minimums, so the temperature below which temperatures will not drop, there's going to be a lot more records set during this event than daytime high temperatures, the first of which might be out by Stockton, where the temperatures on Thursday morning might not go below the mid-60s. But then as we go into Friday, we start to see records all over the map, all the way from Mount Shasta City to Fresno to downtown LA to Indio to Phoenix. These are all Reno not getting below the mid-60s. Truckee maybe not dropping below 60 degrees at night at the peak of this heat wave. That's pretty notable following a period when the overnight minimum temperatures have actually been relatively cool. And even more records on Saturday morning. And then we even see places like Ukiah not dropping below the mid-60s. The entire LA basin, even downtown LA, not getting below the low 70s. Bakersfield not dropping below the 80s. Overnight low temperatures, man, Phoenix, the overnight low of 90 degrees during this heat wave. The Coachella Valley not dropping below the upper 80s even in the middle of the night. So those overnight minimum temperatures will set records. We don't talk about them as much, but they're hugely consequential from a human health and in particular wildfire perspective. As I mentioned, by Sunday, no more daily record high temperatures to speak of in California, but tons of record-breaking overnight minimum temperatures. LA Basin not dropping below the mid-70s. San Joaquin Valley not dropping below the 60s. Again, record temperatures where Reno might not drop below 66 degrees at the coldest point of the night. Phoenix, several days where even overnight temperatures will not drop below 90 degrees Fahrenheit. And places like Medford, Oregon, not dropping below the upper 60s. So this will actually be a heat wave that is more pronounced at night, arguably, and will set nighttime records. We see that a lot in a warming climate, and people often discount it, but again, the nighttime temperatures matter a ton for ecosystems, for wildfire risk, and for human health and recovery, especially if you don't have access to air conditioning, which many people still do not. All right, What else did I wanted to show? Oh, last piece of data here. First of all, the global oceans are extremely warm, record-breaking warmth in the North Pacific. I've talked about how this in the northwestern Pacific has been the case all summer. It's been slowly advancing eastward throughout the summer, and yes, it has now officially arrived along the coast of central and northern California. The northern hemisphere mid-latitude ocean, by the way, is now at a record warm value. We've never seen northern hemisphere mid-latitude oceans warmer than they are today, which makes sense when you look at just how extreme the anomalies are, not just in the North Pacific, but also generally in the North Atlantic at the same latitude. And if we do zoom in, come closer to California, we see that in fact, despite some lingering cool water in patches, maybe just between about the Big Sur coast and Point Conception, now the rest of the California coast and up into Oregon, the water is significantly warmer than average. So starting around about Monterey Bay northward all the way along the north coast into Oregon, well above average water temperatures. That's a huge reversal from earlier this season. And even though there's a cool blob west of the Channel Islands in Southern California, if you look at the narrow region right along the coast, what you actually see is significantly above average water temperatures, several degrees above average. So actually, now, unlike earlier in the season, most of the populated parts of the California coast, like the Southern California Bight and then the Bay Area, as well as the north coast into Oregon, significantly above average water. So this orange and red blob, it was over here earlier in the summer, and then it kept advancing and advancing. It has arrived. The upwelling has, there's still some that's keeping these random cold eddies going, but the warm water has arrived, and this heat wave will likely cement it. So we're going to see a lot of this blue, I think, fill in with yellow and red this weekend as these northwest winds shut down completely that are driving that upwelling. And just to really drive home this point, this is just a trend map. This is how much the temperatures have changed over the past week. We don't see much change offshore, but look right along the immediate central and northern California coast. There's been rapid warming over the past week, which is exactly, I think, what was apparent from the discussion. So, okay, I'm going to bring myself back full screen here and take a look at the questions that are coming in. Just let me take a moment. Take a sip of water here. Thanks for the kind words, folks. There's a comment from early in the session that Tucson, Arizona has recorded a whopping 0.05 inches of rain for the first 2/3 of August. Hopefully this monsoonal surge pushes them out of record dry territory for the month. I hope so too. That's a pretty terrible number. It is true that sometimes individual rain gauges get missed because the nature of the summer monsoon is that it is convective. So these are like scattered thunderstorms. Hit and miss, very heavy if you get hit, but if you get missed, well, you get missed. So hopefully that happens this weekend down there. Otherwise, it's going to be yet another pretty abysmal water year for the lower and upper Colorado Basin. In fact, western Colorado has been doing terribly as well. That too could change this weekend. Fingers are crossed. Yeah, so I don't think this will be a major fire weather event in Northern California, with the caveat that the 10 to 20% chance that there's some dry lightning could change things. And again, I know some folks have either figurative or perhaps literal PTSD from the summer of 2020 dry lightning events. That is about as extreme as they get. Most dry lightning events are not nearly as extreme or consequential in terms of the number or the severity of the subsequent fire ignitions. There was a major lightning event earlier this summer, for example, in the northwestern mountains of California that sparked quite a few fires, and you probably didn't hear about many of them, except perhaps on this live stream or maybe Zeke Lunder's live stream, because they didn't cause significant harm to people or to infrastructure in most cases. That could be a bit different, though, with fires that blow up in Southern California this weekend. Those have a higher likelihood of being hazardous, both due to the higher frequency of people living in close proximity to flammable places in Southern California, but also that we really will see at least 1 or 2 days of quite extreme fire weather conditions from a plume-dominated, hot, unstable atmosphere perspective, with that hot, dry, windy index well in excess of the 95th percentile in some spots. So Weather Talk asks, what causes convection under the influence of this high pressure? So that's a good question, because typically when you have high pressure, and in general, what that means is you tend to have downward motion in the atmosphere, what's known as subsident airflow, so downward vertical motion of air in a high pressure system. At the center of a high pressure system. And so what you tend to see are, in general, that canonically or typically you see clear skies, because you have downward motion, you have air that is descending and warming and thus drying as it descends. So you have inhibition of clouds and storms. That's why in low pressure you tend to see upward motion, the development of clouds and storms. But summer deep moist convection, and I promise you that is the technical scientific term to describe essentially thunderstorms, deep moist convection, that is going to occur sometimes even under very strong high pressure, because the general type of clouds that are inhibited by the magnitude of the downward motion in a high pressure system, it is consistent large scale but weak downward motion. If you have a strong enough vertical kick, you can overcome the inhibition of that downward moving air in a high pressure system. And in a summertime high pressure system, when you have conditions where the atmosphere is unstable and relatively moist, you can actually get these individual thunderstorm updrafts. And thunderstorm updrafts are tens to hundreds of times stronger in the opposite direction in terms of upward vertical motion than the weak but widespread downward suppressive motion of the high pressure system. So what you get is clear skies everywhere except for where there's thunderstorms, and thunderstorms that can sort of break through that downward motion. And paradoxically, high pressure systems can increase the likelihood of the lower atmosphere becoming hot and unstable enough to produce those thunderstorms. That's actually how summer is in most of the world, northern hemisphere, southern hemisphere. You get afternoon thunderstorms in most of the world, except for in coastal California and the coastal U.S. That's actually very unusual, the coastal western U.S. not seeing summer thunderstorms. It's sunny in the morning, it's sunny in the early afternoon, and these big cumulus clouds blow up. That's the mechanism. Occasionally, you will see an environment favorable for that during a monsoonal surge where you have moisture and instability coming from, believe it or not, the desert southwest, where the air is moister and more unstable than it is in California in summer. So when we get those winds to blow from east to west, which is unusual, but that's the definition of the monsoon, by the way. Monsoon is a seasonal reversal of a wind pattern, not an individual storm or an individual downpour. The monsoon itself is a reversal of the winds, which can bring precipitation and storms, but isn't itself that. The reversal of those winds temporarily and episodically from east to west, which we haven't seen much this year, but we'll see this week, is what can bring that kind of situation to California. So there's a question about the DOE climate report. I may try and have a session on that. I'm trying to work on my own public comment, by the way. I did discuss it a little bit in the last session. I may have another session to discuss it, TBD, but it won't be the focus today since there's already, unfortunately, more than enough to talk about at the moment. Half Moon Bay, checking in and loving it, says Loretta. I'm assuming that means you're out of the fog layer now and it's relatively mild and not windy. A rare occasion for Half Moon Bay, but this is the time of year where you'd expect to see it. Susan mentions that it just hit the triple digits in the San Francisco North Bay area. That's pretty warm up there, so makes sense at the beginning of this heat wave. Darius mentions that the new fall outlook from the Climate Prediction Center is coming out soon, and Right now, I would expect that in general, most of the West will be expected to see warmer than average temperatures, as has been the case for most of the West this whole summer, except again for the California coast and for other parts of California, specifically in July. I will point out that May, June, and now August will all be well above average, the long-term average anyway, in across most of the interior of California. That probably will not be true along the central and northern California coast, where this was a pretty cool summer, even in longer historical terms. Let's wait for August to wrap up. I'll show the full stats for the summer once we have them in about 2 weeks, and we can have another conversation about how the fall might be looking then. Question from Randy about the likelihood of storms causing dangerous flooding on the Supai Reservation or the Havasu Canyon and the Grand Canyon this weekend. There's definitely a chance of heavy downpours from thunderstorms, and beyond that, it's almost impossible to be specific. But if there's even a slight chance of thunderstorms in the forecast, if you're in a slot canyon or something in the southwest, my advice is typically just don't do it. Wait for a day or a season when there's a 0% chance of thunderstorms, because it's one of those situations where even if there's only a 5 or 10% chance, if you get that 5 or 10%, you can get into big trouble pretty quickly. And also, that 5 or 10% outcome doesn't necessarily have to hit directly where you are. The nature of those slot canyons is it can be raining heavily 20 or 30 miles away from you. It can be completely dry and sunny, but that canyon channels that thunderstorm downpour to right where you are. So I know that there are a lot of folks who don't necessarily use that degree of caution, but that's one of those things that, as somebody who studies the weather and knows the hazards, I would never be in a slot canyon during a flash flood season on a day where there's a chance of thunderstorms. Every once in a while, even during flash flood season, you'll get a day where there's essentially a 0% chance of thunderstorms, and that's a slightly different situation. But this weekend actually looks pretty active, thunderstorm-wise, after a summer that was pretty quiet. So I can't give you personal advice other than it is thunderstorm season, and heavy downpours are possible anytime there's thunderstorms in the southwest this time of year. Oh, Dave mentions, I think this is in reference to when I was talking about the 100-hour fuels, by the way, that it's in reference to vegetation, dead vegetation that's like 1 to 3 inches in diameter. So think, more substantive branches, more than just a twig, essentially, but smaller than like a tree trunk, for example. And I've talked about this before. This may seem like it's coming a little bit out of left field, but in general, the diameter of the vegetation affects how quickly it responds to ambient weather conditions. So a blade of grass, for example, is going to respond within hours. A downed redwood tree, like a log on the forest floor, that's going to take like a month or two. So that might be a 1,000 or 10,000 hour fuel, as it might be called. There aren't too many 10,000 hour fuels out there, but maybe a giant redwood log or something. In Southern California, mainly what you've got, you have a lot of flashy 1 to 10 hour fuels, the grass, and some of the lighter brush. You also have a fair bit of 100-hour fuel in some spots. You have the heavier brush and some of the smaller trees, the larger shrubs. And there is some 1,000-hour fuel up where you have the coniferous forest and some down trees there, dead and down trees. But it's mostly 1 to 100-hour. But there is, those pockets of 100-hour fuels can be quite dense, and they are really dry right now. Record dry in some cases. So as a few folks talking about the autumn, I'll talk about that more in a forthcoming session. I think I did cover the Puma Mountain Lion 777 question about why high-pressure systems can have thunderstorms. It's similar to why you can get those clouds in the middle of a ridge. Eric mentions the water right now at Huntington Beach is 72 degrees, which is well above the 66-degree average for August. That comports with those plots I was showing earlier. There's a question, does the type of heat at Point Reyes right now, where it's in the mid-70s, quite pleasant day out there, cause the loss of the cooling fog on the Point Reyes Peninsula? Well, yes and no. It's a classic coupled process where it's both cause and effect. I would argue that it's more an effect. So the fog has gone away, and so therefore it can warm up. So the upwelling has decreased, and therefore it can warm up. But there is some feedback effect. The warmer and drier the air is, the harder it is for that fog to redevelop. So it's both chicken or egg, but in this case, it's more that it's a product of the fog disappearing than a cause of it disappearing. Eric mentions that the high-resolution weather models are showing widespread thunderstorms for this year on Southern California mountains and desert this Friday through Monday. I believe it. I think that that's a pretty good chance that will happen, and there's at least a chance of some of those storms will make it into the SoCal coastal zone, including the LA Basin, San Diego, Central Coast, and then a slight chance even they make it up to places like the Bay Area and the Central Valley. So we'll have to see. We'll keep an eye on that. The irony is the farther north and west they make it, the more likely they would produce dry lightning, because the best moisture is going to be closest to the desert southwest in Southern California. The more that lightning manages to make it into Central and Northern California, the more likely it is on the northern and western periphery that those lightning strikes could be on the drier side. So we'll just have to see. All right, well, I haven't gotten a question about it yet, but because we have a couple more minutes at the end, I will entertain the bonus topic of Hurricane Erin. And in doing so, I will bring up some satellite imagery and show it on screen, so you'll see this pop up in a moment. Okay, so, and I'll just double check that you're seeing what I'm seeing here. Sorry, it's taking a minute. There's a little bit of a lag here. This is the only problem with not having a bunch of screens, is I'm not necessarily able to always bring that up in real time here. Let's give me a couple seconds here. Okay, sorry for that, folks. That was a little bit of a glitch. Okay, so what we're seeing on your screen right now, I shifted the satellite view to the eastern U.S. So what you're seeing now is Hurricane, I believe it's Hurricane Erin, and it's spinning. We're lucky this one, and you can see, by the way, you can see the onset of sunset as it moves. This is a geostationary satellite, meaning the satellite's looking at the same region constantly. But obviously, that's the hurricane here. You can see, I'll label it low for low pressure. But it's a hurricane strength low pressure. It's a true hurricane. And so you can see it spinning off the coast of the Carolinas right there. And I'm actually going to bring up a different view. Okay, that since the sunset is here. All right, here's probably the better view. And you can see this was a former Category 5 hurricane that set some records in terms of one of the fastest strengthening hurricanes we've ever observed in the Atlantic earlier. It's not a Category 5 strength now, but it's a strengthening hurricane once again. Again, here I'm going to outline the coastline of the eastern U.S. Fortunately, due to our excellent weather prediction, we are pretty certain that this hurricane is going to recurve and head out to sea like this. But boy, if you think of its long-term trajectory, it kind of did this. It skirted the islands of Hispaniola, it skirted the Bahamas, and then it's kind of doing this now like this. And it's expected to go sort of back out to sea like that. But imagine if we only had the satellite imagery, we didn't have good models or instrumentation, we would have been worried about Puerto Rico, we would have been worried about Cuba, we certainly would have been worried about Florida with this initial trajectory. We were able to tell with pretty high confidence, even when the storm was way out here, that this hurricane, this hugely consequential hurricane, probably was not going to do this, was probably not going to do this, or do, man, the worst case would be something like that. We were able to pretty early on say this hurricane is probably going to just do this recurve. And it's kind of amazing that it's pretty much doing that. Now, all that said, there are going to be some major impacts along the East Coast. There's already major coastal flooding on Cape Hatteras and in North Carolina, coastal North Carolina. So major ocean flooding. In fact, even though this hurricane is going to stay hundreds of miles offshore, some of the worst coastal flooding we've ever observed could occur along portions of the Carolinas with this storm. Thanks sea level rise for that, plus the strength of the storm. Rip currents have already pulled people out to sea. There's major coastal inundation, and there could be tropical storm force winds along the barrier islands out here. So despite staying completely out over the ocean, and maybe not even really producing any rain over land, these are just cirrus clouds, by the way, this storm has at least some potential to cause hundreds of millions of dollars in damage, because it's going to cause major coastal flooding just from the sea level inundation. So we're lucky. The insurance companies are probably dodging a very major bullet with this one. But boy, this would have been a very different story if that trough hadn't come along and picked up this storm, and if this had made instead a beeline for Miami, which it could have, or even if it had made scraped up the eastern seaboard, or if it had done a weaker recurve and, been a new Long Island Express or something. Fortunately, we're now quite confident it's pretty much going to do that, which is a remarkable achievement of prediction. On the other hand, if you know people along the beaches of North Carolina, this is not a time to hang out there, and there may be 5 or 10 feet of coastal flooding there. So that's actually deep, significant storm surge flooding with 40 or 50 foot open ocean waves in this region. All right, folks, I'll answer any last minute questions about Erin, and then I think I'm going to call it a session. Yeah, as Loretta mentions, there's already been over 100 rescues of people who got trapped in rip currents. So sometimes it's hard to describe why, if it's a warm and sunny summer day, why the ocean can be dangerous. But here we are. Any thoughts, asks Zepp, on the system trailing Erin? There had initially been some indications this could be the one to watch and had a higher likelihood of hitting the U.S. Right now, the likelihood of formation is a bit lower, although we'll still have to see. So this is peak hurricane season, by the way. A lot of folks said there have been no hurricanes this season. So, well, the peak is in September. We're not even in the month of the peak of this hurricane season yet. So this has already been an extraordinary hurricane. Fortunately, it's not going to directly hit anything, it looks like. But it may cause some significant coastal impacts nonetheless. And hurricane season is not even at its peak yet in the eastern U.S. There's a final question here. How has climate change affected Erin? Well, to get the exact numbers, you usually need to do more quantitative study, but there's some rapid attribution analyses that suggest a pretty substantial increase in the maximum wind speed with hurricanes like Erin, an increase in achieving the very high degree of very rapid intensification like Erin did, and in the extreme rain rates that occur in these kinds of hurricanes. Now, Erin's rain is pretty irrelevant from a human risk perspective because it's all falling over the ocean, which is great. It's not causing anyone any flooding problems, really. But in any major storm like this, what kinds of impacts are we actually getting in the U.S.? It's mainly coastal flooding. What is the most obvious influence of climate change on hurricane impacts? It's through increasing sea level and storm surge flood risk. So that actually is relevant, and one of the key impacts we're seeing is definitely amplified by climate change. Erin's rate of intensification, it appears that we're seeing more rapid intensification in a warming climate. So that probably has fingerprints of climate change. Maximum wind speed is probably a good 5 to 15 miles an hour stronger than it would have been without climate change. Maximum rain rate in storms like this, often a good 20 to 30 or even 40% higher than it would have been without the warming we've seen. So, some of these numbers are larger than others, and some of them aren't that relevant with this storm because it's not making landfall anywhere. But imagine if it did. Then those numbers would be a lot more important. All right. Well, I think it's time for me to call it a day. I got to finish reviewing a paper on North Pacific climate trends this evening. So with that, I think I'm going to call it a day. I don't have any more live sessions scheduled for this week or this weekend, but as you know, occasionally I will schedule them on short notice if events dictate. So if there is a major fire outbreak, or if the monsoon surge is especially strong, or if there is a major dry lightning event, stay tuned. I might have another session in the next few days. All right, stay cool out there. If you're on the beach, enjoy the fact that it's no longer cool and foggy, and I will see you next time.